Hello. This lesson has to do, or will cover, accuracy, precision, and uncertainty. The first two terms, accuracy and precision, a lot of you may kind of think they're the same thing. They're similar, they're related, but they are different. And accuracy is defined as how close a measurement is to the correct answer. Now, you don't always know that, what the correct answer should be, so this one's a little tougher. Precision is easy to see. It's how close the measurements are to each other. A lot of times in science we will do multiple trials. If you keep getting the same number, very, very similar numbers, every trial, every time you repeat an experiment, it has good precision. So, an example. I know that an object has an actual mass of 5.00 grams. As the teacher, I know that. And I split the class up into 3 groups. And group 1 gets these measurements. 5.03, 3.52, 6.10. You can see that the numbers are kind of all over the place. They're not very close to each other. And they're not very close to the 5.00. One of them is, student 1 is fairly good, but the rest of them are pretty far. If we notice group 2, well, they're not very close to the 5.00, but they're all really close to each other. And group 3, they're all really close to each other. They're also very close to the 5.00. So, how do we describe these 3 groups? Group 1. Well, again, the numbers are kind of all over the place. So that means that it's poor precision, because the numbers aren't close to each other. And the numbers in general are not very close to 5.00, so poor accuracy. So group 1, I would describe that as poor accuracy and poor precision. You could argue that if you took the average of these students, these 5 students in group 1, you end up with an average of 5.07, which isn't all that bad. So you could argue that the average for the group has somewhat good accuracy. But definitely the precision is poor, because the numbers are all over the place. Group 2. Now, the numbers are really close to each other, so they have good precision, but they're not close to our correct answer, which is 5.00. So, good precision, poor accuracy. Group 2, good precision, poor accuracy. And the last group. All the numbers are really close to each other, so good precision. All the numbers are really close to the correct answer, so good accuracy is how I would describe group 3. Good on both. A good way to kind of remember this, and I believe this is in your book too, they have a similar diagram. If you're throwing darts, target 1, they're kind of all over the place, and they're not near the bullseye, which is what we consider the correct answer. So, poor accuracy, poor precision. Target 2, they're really close to each other, but they're not close to the bullseye. So, good precision, close to each other, but not close to the target 2 shows good precision, they're all really close to each other, but poor accuracy, they're not close to the bullseye. Target 3, all near the bullseye, all near each other, so good on both accuracy and precision. Now, uncertainty. Uncertainty is kind of how good our answer is. All measurements have some amount of uncertainty, and all measuring devices have limited accuracy. So, since our measuring devices have limited accuracy, there's always going to be a little wiggle room in our numbers. And that's what uncertainty is. It's that wiggle room. Uncertainty is determined by these guidelines. An analog measuring tool. Now, when I say analog, I mean non-digital. So like a ruler or a graduated cylinder. Something that doesn't have a little computer screen that gives you a number on the screen. So it's something you actually have to measure using little marks on the measuring tool. Now it's the value of the measurement followed by plus or minus half the smallest division on the measuring tool. For digital measuring tools, and those, again, digital measuring tool is something that has a little screen that prints out and shows you a little number on that screen. It's the value of the measurement, so whatever the screen says, followed by plus or minus the smallest division on the measuring tool, which is the smallest decimal place on the screen. So, examples. You measure a piece of metal with a ruler and it reads 12.13 centimeters. Now, the smallest line on the ruler represents 0.1 centimeters, and we talked about how you estimate that last number in a previous lesson. So we estimated it as 3, is a little past the 0.1 mark. So 12.13. Now the way I'd write that, since this is analog, it's a ruler, it's plus or minus the smallest division on the measuring tool. Smallest division is 0.1 centimeters. So it's plus or minus half the smallest division in the measuring tool. So half of 0.1 is 0.05. So the way I'd write that, my final answer, 12.13 centimeters, whatever the measurement is, plus or minus the smallest measurement, I should say, the smallest division on the measuring tool. Next example. You measure a piece of metal with a digital balance, a scale. So you figure out the mass of it, and it reads 2.35 grams. The digital balance goes out to the hundredths place, which is 2 decimal places. And if you look back at our rule, digital measuring tool, it's plus or minus the smallest division of the measuring tool. The smallest division is a hundredths place. So plus or minus 0.01, 1/100th. So that's uncertainty. We won't use this a ton, but it is important once you get further in science and in college to show how good your numbers are. And that is it for this lesson.